All right, so here's day one of our algebra review notes. So first thing we want to do is we're going to be looking at linear functions and equations. So we want to recall our three forms of an equation of a line. So the first one is slope-intercept form. Slope-intercept form has the slope and it has the y-intercept in the equation. So that is y equals mx plus b. So right here we have our slope, which is m, and our y-intercept, which is a 0, comma b. Okay. And our next form is point-slope form. It's called point-slope form because you will see a point and the slope in the equation. So that is y minus y1 equals m times x minus x1, where x1, y1 is a point. So x1, y1 is a point. Notice there's minus signs in front of that. So you're going to take the opposite of whatever number is plugged in. And then that is your point. And then you also have your slope. Your slope is m. And then last but not least, standard form, which is in the form ax plus by equals c, where a, b, and c are constants. Okay, so we're going to do a graph in each form. So the first one right here, if you look, it's in the form f of x equals, or y equals, mx plus b. So we have our slope is 1/3, and we have our y-intercept is 0, comma -2. So b is -2, that means our y-intercept is 0, -2. So remember, we start by plotting our y-intercept, 0, -2, and then we use our slope, rise over run, to get other points on the lines. This is +1 over +3, so that's up 1, right 3. Up 1, right 3. And we're also going to go down 1, left 3 to continue the pattern. Because remember, -1 over -3 is equivalent to +1 over +3. Continue that, and then go ahead and connect these points. And then make sure you put arrows on the end to show that this line goes on forever and ever. All right, the next one here, we have point-slope form. We have our slope, which is -1/2. And then we have our point, x1, y1. So our point is -5, +2. And our slope is -1/2. So you can take the negative with the 1, or you can take the negative with the 2. So remember, it's rise over run. So you're going to go up or down and then left or right. First, we're going to start off by graphing the point, -5, 2. And then we are going to use our slope to get another point. So I'm going to go rise -1/2. So that means go down 1. Sorry, rise -1. So go down 1. Run 2. So that means go right 2. Or you could also rise 1, left 2. So this can be up 1, left 2. So go up 1, left 2. So same thing. Down 1, right 2, down 1, right 2. And then continuing that pattern to get all the points on the line. And then once again, you're going to go ahead and connect these points. Make sure you put arrows on the end to show that the line goes on forever and ever. It doesn't just stop, because that's the graph paper we used. All right, last but not least, we have an equation. We have an inequality in standard form. So whenever you're in standard form, you are going to find your x and y intercept. So first off, let's just pretend it's a line. Pretend for a second this just says equal, and then we'll take care of the fact that it says greater than or equal to. All right, so what you're going to do first is you're going to find your x-intercept, and then you're going to find your y-intercept. So you find your intercepts, graph those 2 points. 2 points make a line, and you're going to end up using that to graph. So let's plug in 0 for y. If we plug in 0 for y, if I plug in a 0 here, it's like this is gone, right? So really what you're looking at is 2x. And remember, we're pretending it says equal for now, 12. Solve that, you get x equals 6. So we know that x is 6 when y is 0. Now you're going to do the same thing. You're going to plug in 0 for x. If I plug in 0 for x, this is gone. I have the equation negative 3y equals 12. Solve that, you get y equals negative 4. And when you plug in 0 for x, you get negative 4 for y. Now I can graph these 2 points, 6, 0, and 0, negative 4. If it was just an equal sign right here, I would connect the 2 points, put arrows on the end, and be done. But since it's an inequality, the first thing I have to do is decide whether this is going to be a solid or a dashed line. Less than or equal to and greater than or equal to is a solid line. Less than and greater than, or I just said them backwards, greater than and less than are a dashed line. So since this is a greater than or equal to sign, we are going to be using a solid line. So first thing we're going to do then is connect those 2 points. I'm going to do a better job of that because I didn't go through them. Okay. All right, so now it is saying all values greater than or equal to 12 for these values. So now what we're going to do is we need to decide if we are going to be shading the values above or if we're shading the values below this line. Here's how you're going to decide. What you're going to do is you're going to pick a point anywhere on the graph. If that is a solution, then that's the side of the line that you're shading on. If that's not a solution, then you're not shading on that line. So I'm going to go ahead and pick 0, 0 because, hey, it's the easiest point to pick. So what I'm going to do is I'm going to plug in 0, 0, and I'm going to plug it into this inequality right here, and I'm going to see if it's true. If I plug in 0 for x, I get 0, 2 times 0, which is 0, minus 3 times 0, which is 0. So the question is 0 greater than or equal to 12? No, it's not. So that means 0, 0 right here is not a solution, and no point on that side of the line is a solution. So what we're going to do is we're going to shade on the other side of the line. All points in that area are solutions. Okay, now you might be saying to yourself, could we have just solved this equation for y and graph that line? Of course you could have. So really quickly, just to show you that it's the same line, I'm going to go ahead and do that. I'm going to subtract 2x from both sides. I get negative 3y is greater than or equal to negative 2x plus 12. And then I'm going to divide everything by negative 3. Now remember, when you're dividing by a negative or multiplying by a negative in an inequality, you do have to remember to switch the inequality symbol. So this would be y is less than or equal to 2/3 x minus 4. So if you look at this line over here, the y-intercept is negative 4. And then if you go up 2 over 3, you do have another point. Up 2 over 3, you do have another point. So it is the same line. The only thing is you have to remember that switching that inequality symbol when dividing by a negative. Okay. Next we have write an equation of a line that passes through this point with a slope of 1/2 in point slope form and slope intercept form. So just so you're aware, 99% of the time we'll be writing in point slope form in this class. Why? Because it's the easiest. All you need is a point and a slope. Slope intercept, you need the slope and specifically the y-intercept. The only point that you can use on the line is the y-intercept. Point slope, it's any point on the line. So let's start with point slope form. So point slope form, remember, is y minus y1. This is y1 right here. This is x1 right here. So y minus 3 equals m, slope, which is 1/2, times the quantity of, so don't forget your parentheses there, x minus x1, which is a negative 2. So we're going to say that's plus 2 because it's minus a negative. All right, so now we also want slope-intercept form. Slope-intercept form, if you look at that as a reminder, it's solve for y. So what we're going to do is we're just going to solve this equation that we wrote for y. So what I'm going to do is I'm going to duplicate this. Oops, I hit delete. I meant duplicate it. I'm going to duplicate this and bring it over here. I'm going to solve this equation for y. To solve this for y, I'm going to have to distribute the half. So I have y minus 3 equals 1/2 x. 1/2 times 2, or half of 2, is 1. And then add 3 to both sides. So we get y equals 1/2 x plus 4. So these two are the same line. If I were to graph the first line, or the second line, so this line or this line, they would be the exact same line. Okay? All right, next one, write an equation of a line that passes through these 2 points. So we're going to do point-slope form because all you need is a point and the slope. We already have a point. In fact, we have 2. So now we just need the slope. The slope wasn't given to us, so as a reminder, let's write down the slope formula. Slope formula is rise over run. So y2 minus y1 over x2 minus x1. We can go ahead and label our points if we want so we don't get confused, but it's not mandatory. This is my first point, and this is my second point. So the first one is 1 and 1. This one's 2 and 2. All right, y2, which is 4, minus y1, which is 3, over x2, which is 1, minus x1, which is a negative 2. So instead of writing minus a negative, I'm going to turn that into plus. So we have 1/3. So now we have our slope is a third. And now we can use either point to write the equation of line. So I'm just going to use this point right here. And there's my slope. So I have, once again, y minus y1, which is 3, equals m, 1/3, times x minus x1, which is a negative 2. Double negative makes a positive. And there's my equation of my line. Now, if you use the second point, you would have had y minus 4 equals 1/3 times x minus 1. So either one of those is fine. You could also distribute the 1/3 and get y by itself, but that's more work. No one asked you to do that. All right, next topic here, we have solving a system. So when you guys learned how to solve systems, you learned 4 different methods, I'm sorry. You learned solving by graphing, so you would graph each line and then see where they met. If they met at a point, that's your solution, because that's where they're both equivalent to each other. If they didn't meet at all, if they never met, there was no solution. And if they're the same line, infinitely many solutions. Now, we don't have graph paper here, so we're not using that. So we also have the options of substitution, elimination, and matrices. This is all no calculator, so we're not going to use matrices. So what we have to decide is substitution or elimination. So what you're going to do is you're going to look at your 2 equations. If there's a variable already solved for, meaning if you see one of the equations is x equals or y equals, you're going to use substitution. If you don't see that, you're going to use elimination. So I don't see that, so I'm going to use elimination. All right, so what I want to do is I want to look at this equation right now and say, if I combine these, so if I combine this, do the x's cancel out? Nope. If I combine these, do the y's cancel out? No. And that's what I want to happen. I want one of the variables to be eliminated. So I want to look at the easiest way to do that. So right now I see that this is a negative and this is a positive. And I see that this is a negative 2 and this is a positive 1. I want them to be the same number but just opposites. So a 2 and a negative 2. And I can get that to happen easily. If I look at 3 and 2 to get them to be the same number, I could get them both to be a 6 and make one positive and one negative, but that's more work. So what I'm going to do is I'm going to keep this as a negative 2y, and I'm going to have this become a 2y. In order to do that, I'm going to have to multiply the entire second equation by 2. So my first equation stays the same. 3x minus 2y equals negative 1. And my second equation becomes 4x plus 2y equals 8. So now what I can do is I can combine these 2 equations. This method is also called linear combination because you're combining 2 lines. All right, combining them or adding them together, I get 7x. Negative 2y and 2y cancel equals 7. Divide both sides by 7, and I get x equals 1. So now I have the x value. Now I just need the y value. So you can go back to your original. You can use either equation, plug in your x, and get your y. I'm going to plug it into the first equation. 3 times 1 minus 2y equals negative 1. 3 minus 2y equals negative 1. Subtract 3 from both sides. Negative 2y equals negative 4. Divide by negative 2. And I have y equals 2. You're almost done, but not done yet. Remember, when you're solving a system, you're finding a linear system, that is. You're finding the point of intersection. So we want to write our answer as an ordered pair, the point where they intersect. X, comma, y. So our x value is 1, our y value is 2. So our solution is the point 1, comma 2. All right, next what we have is we're going to be talking about quadratic and polynomial functions. In these 4 problems here, what we want to do is we want to factor each completely. So what I'll be doing is I'll be going through the steps of factoring. You might want to jot them down if you don't have them memorized or don't have them stored in your brain, because it is a process that you do want to go through each time that you're factoring. All right, so I'm going to say it out loud. If you want to write it down, you can. Step number 1 is look to see if there's a GCF, a greatest common factor. And if there is, factor it out. If not, move on to step number 2. Next, what you're going to do is you're going to see how many terms there are. Okay, so next step is dependent on the number of terms. If there are 2 terms, you're going to see if it's a difference of squares, a difference of cubes, or a sum of cubes. If it's any of these 3 things, then there is a special factoring pattern that you can use. If it's not, then at that point, it's not factorable. If it is, then you factor it. If it's 3 terms, then you are going to use your organizational X to factor it. Some teachers use guess and check or teach guess and check. Some teachers use a box method, and some teachers use this organizational X. I'm a type of teacher that uses the organizational X or guess and check. All right, if it's 4 terms, then you're going to factor by grouping. All right, so let's go ahead and get started. You look at the first example, and first thing I do is say, is there a GCF? So I'm going to look at all 3 terms, 1, 2, 3, and I'm going to see if they have anything in common. So the coefficients are 1, 8, and 12, so they only have 1 in common, and I don't factor out ones. And now I'm going to look at the variables. They all have an A in common. They all have an A in them, so I'm going to factor out an A out of each one, or undistribute it. So if I do that, I have A squared plus 8A plus 12. All right, so now what you're going to do is you're going to look inside your parentheses and see if that is factorable. So I'm looking at this now. Please remember that A does in front, this A right here does not go away. It's just that there's nothing else I can do with that right now. All right, so since there's 3 terms in this, I'm going to use my organizational X to see if it's furthermore factorable. Okay, so when you're using your organizational X, what you're going to do is right here, you're going to write a number. That number comes from multiplying the A value by the C value. And the number you're putting down here is the B value. So what's the A, B, and C value? The A value is the coefficient in front of your squared term. Your B value is the coefficient in front of your linear term. And then your C value is your constant. So I'm going to write what A times C is. 1 times 12 is 12. And I'm going to write my B value down here, which is 8. So now what I'm doing is I am putting 2 lines right here because I'm thinking of 2 numbers. When I multiply these 2 numbers, I have to get a 12. And when I add them, I have to get 8. So if you don't know your factors off the top of your head, you can start listing them. I know 1 goes into 12 times. 2 goes in there 6 times. 3 goes in there 4 times. But you can just do that part in your head. So I ask myself, will 1 and 12 ever give me 8? No. Will 2 and 6? Yes. So my numbers are 2 and 6. Now what I have to do is I have to divide it by the A value. So go back over here. The A value is 1. So I'm going to divide this by 1. And now if it's simplifiable, I would simplify this fraction. 2 over 1 is not simplifiable, and 6 over 1 is not simplifiable. So now what you're going to do is you're going to write your 2 factors. You write this in an upside down method. So this 1 right here is actually the coefficient in front of A. This is an A plus 2. And this is an A plus 6. So let's go ahead and write down those 2 factors. We said we have an A plus 2 and we have an A plus 6. And then don't forget about your initial A in front, this A right here. All right, so now, oops, I didn't mean to do that. So now you are completely factored. How do I know I'm completely factored? Once you've hit linear terms and you've gotten the GCF out, it's no longer factorable. When I say linear, this is to the first power, to the first power, to the first power. Okay, let's move on to the next one. So first off, I look for a GCF, 9 and 49, nothing in common. An X to the 4th and a Y to the 2nd, nothing in common. So no GCF. So now I'm going to look, since it's 2 terms, to see if it's a difference of squares. I'm asking myself the question, is this a perfect square? Okay, is this a perfect square? I like to even break it up even further and say, is this a perfect square? So is this something times itself gives me 9? 3 times 3, so yes. What about this? Yes, x squared times x squared. 7 times 7, y times y. So far, everything's a perfect square. Now I have to see if it's a difference. It is a difference because it's subtraction. So since it's a difference of squares, it has a special factoring pattern. The first two terms are the two terms that multiply to give you 9x to the 4th. And once again, they have to be the same thing. So we already said the 9 was a 3, and to get the x to the 4th would be x squared times x squared. So both of these are 3x squared. Or in other words, 3x squared times 3x squared is 9x to the 4th. Now the next two terms have to multiply to give us 49y squared. Once again, we said that came from a 7 and the y. But notice that it's subtraction right here. So one's positive, one's negative. So this is plus 7y and minus 7y. It doesn't matter which one's plus and which one's minus. All right, so now I am done factoring, but I could possibly not be done due to the fact that this is not a linear term. This is a quadratic. But if you look at this, I would have to assess whether this is a difference of squares. 3 is not a perfect square, and that's not a difference, it's addition. This is a difference, but 3 is not a perfect square, 7 is not a perfect square, y is not a perfect square. So therefore, this problem is done. All right, next one. First thing I'm going to do, remember the directions are factor. Look for a GCF. 1, 2, and 35. Nope. And then x to the 4th, x squared, and no x's in the last term. So no GCF. It is 3 terms, however, so what I'm going to do is I'm going to make my organizational x. Remember, a times c goes up here. Okay, so a times c. A is the coefficient in front of your first term. This is b, -2, and c is -35. So a times c. 1 times -35 is -35, and b is -2. Make your lines. You're looking for two numbers that multiply to give you -35 and add to give you -2. I know 7 times 5 is -35, or sorry, is positive 35. I have to make one negative, one of these numbers that is, so that when I add these two numbers, it gives me -2. Making the bigger number do that will make it a negative number. All right, divide by a. A is 1. And now, once again, I can write these as my two terms. So if you look over here, this was an x to the 4th. This last time, it was an a squared. So I put an a and an a here. So since this is an x to the 4th, this is going to be my x squared and x squared. All right, so I can write my two factors. Remember, you're going upside down or bottoms up. X squared, it's a -7. And x squared, this is a +5. All right, remember, we might not be done because these are still quadratics. They're not linear. So let's assess the x squared plus 5 first. Is this a difference of squares? Nope, it's not a difference. Let's look at this. X squared minus 7, is this a difference of squares? It's a difference, so that's good so far. X squared is a perfect square, x times x. But 7's not a perfect square. Therefore, this is completely factored. All right, so now you might be saying to yourself, well, root 7 times -7 gives you -7. We're going to leave it as just, it's not factorable. All right, last one in this section here. We're looking for a GCF, 2, 7, and 3. There's no number they have in common. X squared, x, and no x's. No x's in common. So 3 terms. I'm going to use my organizational x. This is A, this is B, this is C. A times C goes up top, which is 6. B goes down below, which is 7. I'm looking for two numbers that multiply to give me 6 and add to give me 7. 6 and 1. Divide by your A value, which is 2. And then this is the first time our A value has been something other than 1. So what you're going to notice when your A value is something other than 1 is that at least one of your fractions is simplifiable. 1/2, not simplifiable. 6/2 is simplifiable. It simplifies to 3/1. So you're using 3/1 instead. okay? All right, so look at this term right here. It's an x squared, so this is going to be an x and an x. And now you can write your two factors. Remember, bottoms up, this is positive here, so that's an x plus 3. Bottoms up here, 2x plus 1. And there's your two factors. Okay? If we were to FOIL this out, this times this, this times this, this times this, this times this, we would get 2x squared plus 7x plus 3. All right, last but certainly not least, we have two more factoring problems, and they happen to have their own title called Sum and Difference of Cubes. So what we're going to do is we're going to pretend that we didn't see the directions of this, or sorry, the title of this, and we're going to just keep factoring. All right, so I need a factor. First thing I look for is a GCF. The coefficient here is 1. The other one's -8. The other number is -8. No common factor. And then the first term has an x. The last term does not. So no GCF. So no GCF. So now I'm going to check to see if it's a difference of squares. It's a difference. But x cubed is not a square, and neither is 8. But what you should notice is that x cubed is a cube, and 8 is also a cube. So what this actually is a difference of cubes. All right, so now I'm going to show you how to factor a difference of cubes. You can then try the second one on your own, which is more difficult, but you got to try it, right? All right, so the first thing you're going to do is once you note it's a difference of cubed is I like to write them both as cubes. So x cubed is already written as a cube, minus. And then 8 I want to write as a cube. So what number cubed is 8? It is 2 cubed. All right, so now I need I'm going to use that to help me factor. Now there's a mnemonic device to help you factor, which is called SOPS, S-O-P-P-S. This is to help you remember what to do, okay? All right, so the first thing that you have to do without the help of SOPS is what you're going to do is you're going to write down everything but the cube. That's your first factor. So my first factor is the binomial x minus 2. That's what I have highlighted there. Now, the only other part is a trinomial. And the trinomial, how you get it is using this SOPS reference. So this S here stands for square the first term. So what you're going to do is you're going to look at this term right here and you're going to square it. So that is x squared. The O stands for opposite, meaning take the opposite of this sign. So this is going to become a plus. The P stands for, this P that is, stands for product, meaning multiplication. So what you're going to do is you're going to multiply these two terms. X times 2, and you're not looking at this sign, just the numbers there. The two terms there. X times 2 is 2x. So we have 2x. This P stands for plus, because this is always going to be a plus. And the last S stands for square again. So you're going to square the last term this time. This stands for square the first term. The second one stands for square the last term. And when I say this term, I'm talking about the 2. So square 2 and you get 4. And that is how you factor that. Okay? All right, next, we have one last problem. If you want to try it on your own, go ahead, pause the video, try it, and check in. All right, first step, remember, is getting everything or actually noticing that it's a sum of cubes. It's a sum. 125 is 5 cubed. X cubed is x cubed. Then I have a plus. 27 is 3 cubed. All right, so I got cubed. Now I'm going to write down the base. I'm going to copy the base. 5x plus 3. All right, now I just need my trinomial. SOPS. S stands for square the first term. So 5x times 5x is 25x squared. O stands for opposite. So instead of a plus, I'm going to put down a minus. P stands for product. Multiply these two. This is 15x. P stands for plus. Oops, I forgot my x. 15x. P stands for plus. And then S stands for square again. Square the last term. 3 squared is 9. All right, that's it for today's review of algebra. Everything on this page is Algebra 1 except for the last 2 problems. So you should have learned everything in integrated and Algebra 2. They covered again, but the last two are the only from Algebra 2 with trig. All right, go ahead and start working on your homework.